whether it be on Twitter or Instagram or whatever social media you use, make sure you tweet at FasterSV, hashtag AskFasterDevs, and FASTERCON18. All right, so to get this show going, I want to introduce you to our moderator for this panel. He's a software engineer at Tesla. His name is Nathan Murthy. Let's go ahead and give Nathan a huge round of applause, you guys.
Well, thank you, Romeo. Much appreciated. So hey everyone, we got a little pictures going on over here really quick. If we can soon get everyone sitting down, we can get things started. But I'll go ahead and introduce our panel speakers for the engineering segment of this conference. My name is Nathan Murthy. Thank you again, Romeo. Thank you again to all the organizers, Aaron, Charity, Carlos, Karina, who've been putting this together. This is the second time that I've attended FasterCon, and I'm just really excited to see how much it's growing. So gratitude. I'd like to introduce our first speaker, part of the panel, Lisel Puzon, who is a graduate of Stanford. She's currently a software engineer focusing on applied machine learning at Facebook. So I'll give everyone a round of applause for Lisel. And let's have everyone standing first, and then we can sit down. Second, Elizabeth Bautista, who is the manager of operations at the National Energy Research Scientific Computing Center at Berkeley Laboratories. A round of applause for Elizabeth. And last but certainly not least, Katherine Lowe, I'd like to bring to the stage. It was a good round of applause for Katherine, everyone. She's the director of solutions engineering at Sift Science, and formerly an engineer at Google, and is a Cal alumnus as well. So give everyone a round of applause for all your speakers today. Yeah, go ahead, get seated. So each of the speakers has their own slide deck prepped, and I'll go ahead and pass the clicker off to Lisel. But before we jump into who they are, their story, and what they do in technology and engineering, I kind of just want to open it up to a quick and fun sort of icebreaker question, since it's early in the morning. We just want everyone who's probably half awake like me wants to be engaged. So one quick question I have for each of you, Lisel, Elizabeth, and Katherine. What is your favorite Filipino breakfast food? Favorite Filipino breakfast food?
For me, it's longganisa.
Yes.
Okay, old school. Bang silog.
Yes.
Same.
Can't go wrong with the silogs. All right. So you go ahead and hand off this clicker. Use this clicker. Oh, you got it. Okay, great. So Lisel will be the first up. Take it away, Lisel.
Hi, so as Nathan introduced me, I graduated from Stanford in 2017, and I've been working at Facebook on applied machine learning, specifically on machine translation. So just to give you some context about the work that I do, so you might have seen some articles about Facebook launching new language directions and unsupervised translation. So that's kind of the work that I do. It's somewhere in between this product applied perspective and the research side. So we serve 6 billion translations per day. And at that scale, you really can't do any manual translations. So we use neural networks to automatically translate between languages. And so this is some of the research that we do as well. So right now we're working on unsupervised translations and continuing training for multilingual systems and other forms of neural networks like that. That's it.
Everyone take a picture of this last slide. It's good to stay in touch. Connecting is important.
Say when.
Everyone Everyone have it? Okay. All right, I see all the phones coming down now. Let's go ahead.
So I'm Elizabeth Bautista, and I'm the manager for operations for a supercomputer center for the Department of Energy called NERSC, National Energy Research Scientific Computing Center. Quite a mouthful. It takes a team, several teams, to run a supercomputing facility, and my group is the site reliability engineers. So we make sure that the facility is running 24/7. And this is for computation, data storage, basically the environment, the facility environment, and the wide area network. My team also does research in power utilization and data center efficiency. We have a cutting-edge open source data collection, which we have basically terabytes of data that we're now in the process of validating and cleaning up, and within a couple of months we're going to be able to do some power efficiency analysis. And the reason why we're doing this is because our next big system is coming in toward the end of 2019, and the limitation on that is space and power. So we want to make sure the next system that we get is very power efficient in a smaller footprint, basically, that can fit in our space. Let's see. So I'm reading off of this because I can't see that. Let's see. So I'm also the founder for Filipinas in Computing, which is a tech community with the Anita Borg organization. And we are actually at a conference that just happened a week ago called the Grace Hopper Conference. Yes, there are people who actually know it. Yes. And so I'm the founder, and this year our chair is actually in the back. Her name is Miriam, and she's going to be having her own talk this afternoon, so please come to our talk. And I was actually nominated and voted as one of 100 most influential Filipino women globally by the Filipino Women's Network, which is another community of Filipinas. And this is a whole bunch of CEOs and builders and basically, Filipino women who just strive in their industry to become really good at what they do. Next slide. So other cool stuff about me, because I was told I'm supposed to do that. I'm an immigrant. I wasn't born here. I actually came here when I was 8. As you can see, I'm a big Disney fan. I love to travel. I love theater, mostly opera and musicals. I actually have a program that teaches coding to young children, and believe me, I've used this on my college freshmen too, using the platform of Dash and Dot. Has anybody heard of that? Oh, yes, awesome, cute little robots. And then I'm an advocate for diversity in STEM, obviously. My favorite Filipino food is lechon kawali and pinakbet, and as I was pasting that up there, I'm like, oh, I really want Filipino food today. And I guess all of us at some point are going to publish, and I'm an author as well. My social media of the 2 community groups that I mentioned, and my contact information.
Great, thank you, Elizabeth. Everyone take a picture of this? Oh yeah, are the slides available at all online that they can download?
Yeah, we'll do it later.
Cool, Erin said we'll provide a link to download that for you all later. Let's go ahead and move on to Katherine now. We'll share her slides.
Hi, I'm Katherine. Whoa, this is loud. Sorry. So I'm not as prepared in terms of slides. I'm really sorry. I started with the fun stuff. So I was born here, moved to the Philippines, and some weird thing. My parents thought it'd be fun to move there, and then came back. I blame going to kindergarten in the Bay Area on the fact that I hate singing and dancing, and I'm pretty sure I'm the only Filipino who can say that. But there it is. My favorite Filipino food is kare-kare. And I graduated from Cal in 2008, and I was involved with a couple of pill orgs. I had no idea I would end up in tech when I was an undergrad, despite minoring in computer science. I thought I wanted to be a lawyer. So that's, life leads you in mysterious ways, and it's worked out a lot. So now I'm at Sift Science, which I meant to fill in the slide, but I didn't. We're a venture-backed startup, Y Combinator. I've been with the company for about 5 years, where now I lead solutions engineering. What we do is we fight fraud using large-scale machine learning. So the idea is whenever you buy something online or post a profile on OkCupid or whatever you use, there are a lot of bad actors out there, and we work with companies to help them figure out whether or not their end user can be trusted. So is this a real credit card? Is this a real profile? Is this a real job listing? And we do that using machine learning at scale. So we've been doing this for about 7 years now. I've built out the team that interfaces between product and engineering and our customers and sales. So it's a kind of in-between technical role where you're talking to people, so-called solutions engineering. I found that a lot of people don't know these roles exist, but there's lots of them out there that bridge the gap between being engineers who are writing code and designing products and salespeople who are talking to customers and getting money. So the core role of my team is to make sure customers know how to use our product, set it up well, and then make sure that their needs are understood by the customer's needs are understood by our product team. I do not have a slide of contact information because I am a lazy person, but if you would like to get in touch with me, my email address is neonpink@gmail.com. So it happens when you make a Gmail address when you're 16.
Thank you for that, Katherine. So let's go ahead and jump into some of these panel questions. And we'll just go from the audiences left to right as I ask these. So, first question for Lizelle, since you work at Facebook, tell us what you do. Like, why is AI and machine learning important in what you do?
Sure. So our team's vision is to break down language barriers across Facebook so that people can communicate with each other, not even have to understand the language that anyone else is speaking. So AI is really important because of just the scale of content that people produce. Like right now, we just started doing translations in Messenger. So these are all the same systems, all the AI models that we train for Facebook are also used on Instagram, Messenger, Workplace, all of our products. And so AI is super important to serve all of these different platforms. And yeah, so day to day we mostly work on just improving quality overall. So that involves a lot of research, kind of reading papers and talking to people on the team. We have reading groups and try to implement the latest technique to make sure that our quality is up to par for all of our users.
Great, thank you for that. And so Elizabeth, so tell us a little bit about what you do. Why is high performance computing at the National Energy Research Center important in what you do?
So high performance computing is essentially doing computing on very, very large computer systems. Used to be mainframes. These days it's very large computer systems. And at the lab, we basically accelerate science. So whenever you're doing any kind of computation-science, you further the science so much faster than if you were just doing things in the lab. And you can do things like very fast computation, and that's primary part, but you can also do simulation, you can also do data analysis, you can do visualization on these very large systems. And we've seen science accelerated by years just by doing a lot of that work on a supercomputer.
Amazing, interesting work. And for Katherine, so tell us a little bit about solutions engineering. What is solutions engineering? Why is it important? And how do you use machine learning in what you do?
Sure, so solutions engineering is, a lot of companies also call it other things like sales engineering, or Palantir calls it their forward deployed engineers, but it's any engineering role where you're working very closely with customers and prospects to make sure they know how to use your product correctly. We're an ML-based product. It actually makes a huge difference how you end up implementing our solution on whether or not you get good results. So for example, if your customer is ordering a shirt, and you send it a shirt size, if you tell us shirt size 2 and 4 or 6 or whatever women's shirt sizes are, and our ML system ends up thinking that's an integer, you end up with an average fraudy shirt size of 3.8, which is not actually a shirt. Versus if you set it up correctly, which is where my team comes in handy to help you figure out how to get the best results out of your machine learning. You end up treating it like a string where you say, hey, different shirt sizes are kind of discrete buckets. And so you might have the Friday shirt size of 4, which is actually a useful thing that our customers can act on. So with any complex technical system, you need somebody who's translating it and making sure that people use it correctly, and that's our role.
Great, thank you. So you can already tell from the speakers here and prior to us that there's a lot of synergy in what they do. You know, we have high performance computing, machine learning, AI, chips that are application specific to running AI programs. And I just kind of want to open it up now to the speakers to kind of popcorn on some of these topics of interest to our audience. And maybe, feel free to get a little technical since this is, after all, a very STEM-specific crowd we have here. What are some things that you were excited about between your respective disciplines? All the way from the bottom of the stack at hardware, all the way up to the top of the stack where you're building applications for end users. Feel free, anyone wants to jump in first on that.
All right, so yeah, I guess I'm really excited about, so one thing is we just launched our platforms to be open source, so you can actually train the same systems that we have training for our production systems on your own data. So I think that for me, it's about like this collaborative environment that we do research in. So we collaborate with other research teams in Facebook, AI research, and really it's about the intersection of producing techniques that actually make it into a production system. So for example, the best translation system is not fast enough for our use case, so we have to do a lot of techniques. So for one thing, we have to optimize the output projection layer. If you've heard of, on the inference side, if you've heard of any machine learning techniques, basically this reduces the amount of matrix multiplications that you have to do at the very end. So this is like one kind of technique that's specific to our production systems, but you don't really see as much in research. So there's like a in-between there where you have to consider a production environment and also try to use cutting-edge technology.
And speaking of cutting edge, are there a lot of these computations that we're doing with matrices, linear algebra? Are there anything that you do, for instance, Elizabeth, that focuses in on optimizing those type of operations for these type of problems?
All the time.
Yeah, tell us a little bit about that.
So part of the function, so this is another group, we call them consultants because they are the software developers. And they basically, they are field scientists themselves who have become experts on the software that scientists in their field uses. And so now they come into one of our facility groups and help scientists. So what they do is they help them write better code so that they can run things on our systems. And the thing is, every 5 years or so, we've got to switch up to new systems. And so we're constantly having to make sure that the applications that the scientists are using will be ported to the new system. And because we're a non-classified lab, we serve more of the scientific community. And so instead of like Oak Ridge National Lab or something, who's got maybe 60 different software application codes for different scientists, we probably have 650. So we try to port those, every so often. And part of all that is to try to ensure that the scientist code becomes more efficient as the more modern system comes along.
Yeah, efficiency is definitely important when we're trying to build, even on the scientific end, things that perform quickly enough so that over time, right, we can improve the way scientists can load data or run models on your computing systems, right?
Exactly. And the thing is, for a scientist, if it ain't broke, don't fix it, right? So if the old system is running just fine, why are you getting rid of it? And so we always have to show that by porting this code onto the new platform, it's going to be more efficient, you're going to run your code faster. It isn't going to take 48 hours, it's not going to take 40, as a first pass, for example.
And Katherine, tell us a little bit about what you're excited about as well in this kind of space as well.
Yeah, so I think how fast things are getting, kind of generically. When I joined Sift a little under 5 years ago, there was no way in heck we could put a neural net in production. They're just a 20-person startup, couldn't afford it, it wasn't practical. I actually gave a talk at Grace Hopper about the practical implications of machine learning and how, there are lots of things that sound cool in academia, but you just can't do them in production and in real life because the data's too messy and it's too expensive. We're now getting to the point where we can productionize these systems because things keep getting smaller and faster and cheaper, essentially. Kind of on a personal note, though, I do love the move towards ML and AI. I took 188 when I was an undergrad here, and I never thought I'd use it again. And lo and behold, I ended up at a machine learning startup where suffering through that class was worth it. So that's been very fulfilling for me.
So just to get a show of hands from the crowd, who here has taken even introductory courses or even watched like a 2-minute YouTube video on like AI or machine learning? Okay, great. So there's a good number of people who have introduced to some of this stuff. So one of the challenges that I see in this space, or a big challenge, is that, for instance, in machine learning and AI, where you have these large weight matrices for huge problems, for very large data sets, on typical computing systems, even on accelerated GPUs today with the memory bandwidth that's on them, it's difficult to fit that entire matrix on that chip, just due to the memory constraints of that system. So one challenge that I see coming up in the ASIC space, so for instance, Google recently open sourced their cloud TPU product, their TensorFlow processing unit for some of these AI problems. And they just have tremendous memory bandwidth that you're able to load in on their systems. So a big challenge that I see, for instance, is the hardware being able to keep up with the data that we're collecting, and that the software engineers, they're ready to do, but just don't have the tooling, right, and infrastructure that we were talking about earlier. Did you see similar challenges day to day in the kind of work that you all do?
I guess I don't directly work with the infrastructure side of things, but we do have really close collaborations with a team called Onyx at Facebook. So it's basically a way to export PyTorch models into we use like a Cafe2 graph, which is, I guess the difference is like TensorFlow interactive mode is similar to PyTorch, and then TensorFlow, where you have to pre-build your computation graph, is similar to Cafe2. So there's an intermediate layer that we just launched this year. So we actually did a huge migration, like Elizabeth mentioned, every time something new comes out, you have to migrate to a new system. So we've recently migrated all of our code from Cafe2 to PyTorch, just because it's faster and enables more collaboration. And then we use Onyx Export to productionize that code, basically export that graph into something that we can load onto a machine and run very quickly. Because PyTorch, if you try to do inference on GPUs, it's just gonna be an exponential cost. With this, we can run inference on CPUs and train on GPUs. So it's like the best of both worlds. And yeah, there's always gonna be new infrastructure and libraries that you have to use to make your code efficient.
And do you experience similar challenges as well, Elizabeth, and kind of problems you're solving?
Oh yeah, absolutely. Kind of on a really wide global scale. Have any of you heard of the concept of super facility? Oh, okay, ish, right? So essentially, super facility is supposed to be, think of it as computation on a global scale. And the way we're thinking about it at the National Lab is that computation, data storage, and the transfer of your data and the processing of your data doesn't have to happen in one facility. And that it should happen in whichever facility has the most efficient resource available to you. Part of the challenge of that is we've got terabytes of data sets. And traditionally, it's been the network that's been the bottleneck. And so part of being able to do this large data transfer is to be ahead of the game. So here we are, we've got the Department of Energy has their own, think of it as their own ISP. We've got our own network, basically. And part of the conversation that we were having with the organization that manages this network, that puts in the infrastructure for this wide area network, is that they were saying that, oh, from our facility to another facility, we're expecting to go at about 300 gigabits. And we were like, no. In 12 months, we're going to need 400 gigabits. And so they can't even imagine that we're going to need that big of a pipe to move this data. And yet here we are saying no, because we've got data sets and we've got computation that happens from one lab to another, from a university to another, that is going to need that pipe. And so for us, and what's really exciting for me is having to challenge another organization and say, these are our needs, and you're going to have to provide this in the next 12 months in order to keep up with the other labs and with all the research that's going on in science.
How about yourself, Katherine? Do you face similar challenges as well?
No. I mean, I'm sure our infrastructure team does, but I am thankfully a little bit distant from that. I tend to run into more issues like data in the real world is not as clean as we'd like it to be, but that's a whole other can of worms.
And so, as we're chatting about these different problems, I'm a very firm believer in open source when it comes to software. And the value add that I see there is you have these free tools that are readily available at your disposal that any of you all could just pick up and download and just clone today on your laptops, right? Are there any tools that maybe, you mentioned like PyTorch, Cafe, we're talking about TensorFlow. Are there any open source tools today that are just so cutting edge or are so primed for future use that, whether you're doing production development or if you're working on scientific applications, that you just have to know or are a requisite in this space? Open questions to you all.
So let's see, about 3 years ago, we are getting ready to move back to the Berkeley lab facility from our Oakland facility. This is moving the data center, and part of the challenge we had was that we wanted to capture data from the facility itself. And so another group had this infrastructure that was collecting data in Oakland, and it was constantly crashing because the database wasn't quite working, or it wasn't quite accepting the kinds of queries we wanted. Every time we gave it a complex query, the darn thing would crash, and we were paying a license for this. So, does that sound familiar? And we couldn't quite get the development out of this company that we were paying a license for, which was really frustrating. And so, my team and I decided, well, you know what, we're not going to have that group manage this because there's going to be so much data. We're anticipating so much more data to collect from the facility. And so we decided to go open source. And so we used this stack called Elastic. And we started looking into this, and it was open source, and we thought, yeah, I think we can do this. And the thing is, we're collecting now 15,000 data points per second. And we are stretching this open source product to its very, very limit. And the thing about scaling so huge is that in open source, there's no one out there who can help you. If you're not doing something everybody else is doing, you're basically a pioneer. And so to me, it's scary because we have to keep this system, this cluster in production to continuously collect data. And yet, every time there's something new we wanted to do, there's no one out there to ask. So my engineers and I have to be the ones to figure it out. It's exciting, it's cutting edge, and very scary as well.
It's a fun space to be in, right? There's a lot of learning happens at that edge, I feel, and that happens for me personally as well. In adopting and learning about new things that are out there. Because I feel like every day there's like a new open source thing that's out there that I didn't know existed. What about yourselves, Lizelle and Katherine? What were some open source tools that you would recommend?
Yeah, so I don't have anything specific, but I think for my kind of role, it's really more about just being able to find the tool and learn things quickly and be really excited about learning different things. As somebody in a role like mine moves from company to company and industry to industry, your skill set is going to have to change. The technologies you work with are going to have to change. And even what I was using when I joined Sift 4 years ago, and what I'm using now are completely different. What I use here and what I use at Google are completely different, because at the end, I'm kind of a consumer of what engineering and product put out, and I have to figure out how to make that work with our customers. So it's really more about, I always use the example of like, you can try to build a perfect rocket ship or you can build it out of duct tape, but as long as like the thing moves, like that's all I need. So it's really more just learning how to Google things and ask your friends and kind of duct tape it all together.
Oh yes, know how to Google search well. That's a very good skill to have. Would you like to answer that?
Yeah, sure. I guess I already talked a little bit about like PyTorch and everything. So one thing is, yeah, like Elizabeth and Katherine said, sometimes you're gonna have to like actually dig in and change some of the things in the framework, and because these frameworks are open source, you can contribute directly to them. So we've had instances where, like, our team maintains PyTorch Translate, which is an open source library, but we depend on FAIRSeq, which is a more general sequence-to-sequence library. And a lot of times we've had to contribute code back to them, and they've contributed back to us. So collaboration is really a two-way street. And if you can build those relationships with the open source like maintainers of the libraries that you're like working on and using, then that's super valuable for your company, and even like for yourself, for like building your own network. So I mean, even in high school, I started developing open source for this competition called Google Coding, and if any of you are high school students, you should check it out because it's really cool. But basically, you develop for an open source library, and if you meet some thresholds of like work, amount of work that you contribute, then you can get like some kind of scholarship or something. So yeah, I definitely really believe in the open source community and contributing and using tools both ways. Yeah.
Yeah, and contributing, both using and contributing to open source. You know, putting that on your resume and being able to say that you can do these things, you know, is a huge plus when it comes to employers and finding prospective jobs. And I know we have a lot of students in the crowd today, professionals as well. And so the last question I have before I open it up to the audience for you all is, you know, what is some advice that you could give to a younger version of yourself, to people in the audience, to all of us here? You know, some tidbits, maybe advice either on maybe getting a job or getting the thing, landing that one dream project or that dream position.
Yeah, so for me, I think it's think about what really motivates you. I think, and so I'm now in a management role. I manage a team of 21 people, and I found that that's the thing that's really exciting for me, being able to both manage other people and help them have, it really gives me a multiplicative effect on the company. I empower other people, they can do more work than I could ever do alone. But it took me a little bit to figure that out, because initially it's like, well, I want to have complete control over what I'm doing and my projects and own that. And also I thought that the thing I wanted to do originally was build cool stuff, but I figured out both that building is fun, but I enjoy it more as side projects. Solving people's problems and making people happy is much more motivating to me, and that comes through for me working with customers and then eventually managing people and mentoring managers to becoming a manager of managers, and that's been, I think, the thing that's been really fulfilling for me, but it's not what I would have ever guessed I'd end up doing 10 years ago. So, you know, be open to it, think about what really motivates you, not just, you know, what the media and your friends think is cool.
So I do a lot of outreach, and I encounter a lot of students who are CS students, and they tell me, yes, I'm a really good coder. I want to be a system developer, software developer, or some kind of developer. And the thing is, what my experience has been, at least in my area of computing science, is that along with the coding, the software development portion, you really need to understand some other area, like system administration or network engineering, because what you're coding in, at least in HPC area, is something for that. So just learning how to code, it isn't so much fun not really knowing what you're coding. But if you understand the systems, for example, and that when you're coding to make the system more efficient or the kernel more efficient, then it becomes really more exciting. So, we're constantly talking about being very deep in your technical understanding, but I encourage you to also be horizontal in your understanding of what's going on in that company, and it makes you a little bit more flexible.
So would you like to share some advice to me?
I guess this is more like advice that I'd give to myself. I think that reaching out to potential mentors or people who have already gone through like the thing that you are, like, for example, applying for jobs, like that's super valuable, and like most people are willing to help and like give you some tips if you ask. But I guess I never really reached out like that, and I think that you guys have the opportunity to reach out to like all the people here and like other mentors that you have in your network. And it doesn't have to be like a formal mentor relationship. Like it could just be like a question and like a personal connection. That's like, I think that's more than enough, honestly. Yeah.
Thank you all for sharing. Let's go ahead and open it up to the audience. I think we have someone running microphones that pass around. We could probably get a microphone from here and just pass out as well.
Well, that is all Panay. So, shout out. So, I come from a non-technical role, and there may be folks in the room who also identify that way. But I work with engineers every single day. So, from your perspective, if you can identify this way, how do you find value working in cross-functional teams? And where have you seen that balance work really well? And where do you find there is room for growth and opportunity to improve that?
So I'm an advocate of really good workforce development. And part of the challenge for us is to hire, it takes us a long time to hire the right people. And one of the conversations I was having with our management team at one of our strategy meetings was that the thing is, we're constantly advertising and we think we're going to attract talent in the same pool of people. And the funny thing is, I asked the group, there's about 20 of us in there, and I said, you're looking for a systems engineer, and you're advertising in the same space, HPC wire, IEEE, ACM, the same space. And yet, you're seeing the same type of candidates. You're not seeing a diversity in your pool of candidates. And that's because you've got to reach out wider. And I asked this group of people and said, how many of you actually don't have a CS degree? And lo and behold, about 3/4 of this group raised their hand. I said, so then how did you get into tech? And then you hear the story. So as a person who has non-traditional tech, or somehow you got into tech non-traditionally, my advice would be understand the business of what you're getting into. A couple of years ago, I had a student come up to me and say, I'm from San Francisco State and I'm a business major, but I really want to work in HPC. How do I do that? And the thing is, you have to have a conversation with that person. What do you like to do? What do you know how to do? And then you have to be able to bridge and apply that into your tech area. So the thing is, here she was a business major, and there's a business of tech. And you have to understand what the tech of it is, but you also have to understand the business. So she learned how to do procurement on big systems. She knew how to do financial forecasting for what it is we're going to do in 5 years, and how are we going to apply to DOE in order to be able to get financing for that. What is the financing of the tech itself? Is it just the machines? No, you also have to think about the facility. How are you going to finance what upgrades you're going to put in the facility? How much power are we going to get? How much more cooling are we going to need? And all that has to be thought of. So it isn't just the one area. So whatever it is you do, you have to think about what is it that you can do in that tech space that you can contribute to. And you hope that in that organization there's a manager who says, yeah, I can open my mind and think of something that you can actually do within my organization.
So, kind of quick. I think a lot of it, if you're at a company or you're part of a company and you're thinking about like, how do I work with the non-technical half of my company? And it, to me, has really been a cultural outlook. So when I left Google, if you were an engineer, you could request nicer headphones than if you were a non-engineer. That's not the case anymore, they fixed it. But it's surprisingly systemic throughout Silicon Valley that we hold up engineers to be this like, I don't know, super cool persona and they're better than everyone else and so on and so forth. But I think at the end of the day, actually I know that at the end of the day, you need business people, you need designers to make the thing, you need engineers to build it, and you need everything. And so for a company or a team, a lot of that comes down to culture. Figuring out how do you work with people and how do you make sure that people are respectful and ask for opinions across the aisle and work together. So like things we do, we all eat lunch together at the same time every day. It's a little bit culty, but it means all the engineers know all the salespeople, they play ping pong together, they play Smash Brothers together, all these things. But it's just making them see each other, both sides, as people. Not just like, oh, there's a sales dude over there, or oh, there's that nerdy engineer over there. Because, you know, at the end of the day, we're all people. And, you know, like I've actually personally managed somebody out because they refused to talk to non-engineers, which sounds crazy given my role, but they did. So we decided they weren't a good fit for the team and managed them out. And I think you have to put your money where your mouth is, and if you think that cross-functional collaboration is important, which I personally think it is, your organization has to get behind that and really emphasize that and not be willing to say, oh, this person's really mean to all non-engineers, but they're so brilliant, that's okay. Like, you have to make sure that that's not okay, and that they're either working on it or they're out.
Okay, I think we have time for one more question from the audience, and then we'll wrap up this segment. Yes. Let's get someone from maybe on this side over here.
Mike?
Or if you can project, yeah, go ahead.
Mike, yes. This is someone who drove up from LA, so you get the last question.
Thank you. So good afternoon, my name is Josh. Yes, I did drive from LA. And similar to Evelyn, I'm also from a non-technical background. And actually I wanted to build on that question because for me, I had a very circuitous route to get into tech. I'm a political scientist. And it took me 4 years before I landed the job that actually allowed me to come back to the US. I was in the Philippines for several years. So I guess the question there for me is, I know there's a lot of talk about managing cross-functional teams, talking about how we can work together with people in different roles. But I guess the question for me is, for those that are starting out, for those that, you know, for some odd reason decided, I want to get into tech, but I don't have the right background for it, how would they get in, given that for a lot of these companies, and this is absolutely no offense to any employers in the room, a lot of the pipeline is slanted against non-technical people that are looking to enter roles in these companies or organizations?
I think it depends on what you want to do. If you look at it and you go, you know, in X years, I want to be a senior machine learning engineer, like, you should maybe think about either side projects, contributing to open source, going back to school, things like that. But if what you want to do is work with technology, work in a role where there is no code, it's a matter of finding roles that value that mix of skills. So one of the teams I lead at Sift is what I call support engineering, which is essentially an entry-level role where we're hiring people fresh out of college who are either extremely technical or extremely people-facing. And the goal is to ramp people up into being sales engineers, solutions architects, and things like that, and get them, if they needed the technical exposure while they're there, or if they needed the customer exposure and like business case exposure, and figure out like you have a minimum standard for being a analytical mind and not being afraid of tech, and being able to put on a shirt and iron it and be in touch with customers. But then we will help you up level your skills. I think it's all about because there are very few people who want to get into tech and have a strong set of other skills. You just have to find a company and a team that value that.
Unfortunately, we're out of time for this panel, but I love the discussion that's been happening so far, and hope that during the break and lunch that we can extend these out all to the cafe and outside. So thank you again. Let's give a round of applause again to our speakers.